Charlie, Daniel, Fernando, Isaac, Jake, Junjun, Justin, Lori, Moran, Olivia, see we have a lot of them not here with us yet, but I'm just gonna hand out the trophies first. Looks like you guys have done your homework quite well. Was it difficult or did you guys find it easy? Easy? Okay. And you guys still remember what we went through last time, right? Haven't forget about it. Yeah, mix and match, that's right. So today we're gonna look at something a little bit different, but I think you guys will find it alright as well. We're about to start soon. And I just want to make sure that you guys all have a paper or something that you can write on for today, because I do prefer that you guys can draw it down as we go through it and do the question literally on the paper as we're doing it. Uh, yeah, well, you can draw it on your notebook or on your iPad or something like that, as long as you can, write something down. Yeah. Okay, I think we'll start the lesson for today. Let's bring up the PowerPoint. Okay, so today we're gonna have an introduction to lines. Okay, so in math, we encounter line segments, rays, and lines all the time. They're actually everywhere in our life. So do you recognize them in our life? And Wukong said, Sir, I'm not sure. Can you show me some examples? But look at these pictures. Okay, so we see in picture 1, the line segments are highlighted with red color. You can see the red lines over here, yeah? And then in picture 2, the rays are highlighted with red color as well. So these will be the rays in picture 2. And then in picture 3, the line is highlighted with red color. So you see this line here. It's not quite obvious, but it's just here. Yeah, don't we have them everywhere in our life? Wow, but how do we differentiate a line segment, a ray, and a line? Okay, we will discuss them in detail in this lesson, okay? This is what we'll be focusing on. So let's get started. So what is a ray? In a figure below, this is a ray, okay, which has only one endpoint. You can see the endpoint here in orange. There is a straight line starting from this endpoint and extends indefinitely in one direction. Okay, so we see the endpoint here in the orange, and then we can also see this black line starting from this endpoint and extends in one direction indefinitely. Okay, so let's give it a bit of a try. Which option below is a ray? So I want you to remember that the characteristics of a ray is that it has an endpoint from which a line starts in one direction, okay? So out of A, B, C, and D, which one do you think is a ray? I'll get you guys to type the answer in the chat box. Yeah, okay, so I can see a lot of C, which is the correct answer here. Why is C correct? Because we can see an orange endpoint here, right? And then a line starting from it. So that satisfies the requirement of being a ray. Why don't we say A is a ray? Because first, we don't see an endpoint, and second, the line doesn't extend in one direction indefinitely, right? It closes up. What about B? B doesn't have any endpoint, so B doesn't qualify as being a ray. And what about D? Too many endpoints, right? We have two, but we only really need one to be a ray. Okay, so are you guys getting the idea of what a ray is? Yeah, that's good. Okay, so we're gonna have our first ask question. So how many rays are there in the figures below? So we'll look at question 1 first. We're gonna find the number of rays in the first figure. So what we're gonna do is that we're gonna locate our endpoint first, because the ray has one endpoint in which the line extends indefinitely in one direction. So we're gonna start with finding the endpoint, which is here, right? And then we could have a line extends from this endpoint and both towards the left direction. So we could have, let me just bring up my pen. We could have it starting from the endpoint towards the left, or we could have it towards the right. So how many rays do we see in the first figure? 2. Okay, now let's have a look at the second one. So there are 2 endpoints in figure 2, starting from point, we're going to call this point A. So we're going to call this point A, and we're going to call this one point B. So let's start with point A first, yeah? So from point A, we could have, again, 2 lines, yeah? Towards 2 different directions. And what about point B? Starting from point B, we can have one towards the left and one towards the right as well. We'll draw a little endpoint there just to make it clear. So how many rays can we see in the second figure? 4. Yeah. And then we're going to look at the third figure. So in the third figure, we have 3 endpoints. Yeah, we're going to call them A, B, and C. So starting from point A, we could go to the left, that is 1 ray, or we could go to the right, the second ray. And now let's look at endpoint B. So starting from point B, if we go to the left, we have a ray there, or we can go towards the right, another ray. What about C? Again, 2 more rays. So how many rays do we see in the third figure? 6. Yeah, good job. So does anyone have any questions about how we found the rays in these figures? No? Okay, that's good. We're going to go to the next slide. So in summary, to find the number of rays on a straight line, every endpoint will create 2 rays. Remember in the question that we did on the last slide, every endpoint we can go towards 2 directions on the line, yeah? And that creates 2 rays in total. So we can find the number of endpoints first on that line, and then we can add this number of the 2's to find the number of rays. So for example, if there's 1 endpoint in this line, we just have 2 rays in the figure. And if there are 2 endpoints on the line, we will have 2 plus 2, which equals to 4 rays. And then if there are 3 endpoints on the line, we'll add 2 by 2 by 2, which gives us 6 rays. Okay, Misha and Emily, uh, can you tell me which part do you not understand? Is it about the endpoint or the adding the 2's? So I'm just gonna go through that again because every endpoint we can have 2 rays, right? So that means for every endpoint that we see, we're gonna plus 2. Okay, so you don't understand. Okay, the ray has to have 1 endpoint and a line extending from that endpoint towards one direction indefinitely. So it will look something like this. So um, I'll draw a ray for you. So you have 1 endpoint and then a line extending in one direction indefinitely. Does that make sense? Or let's see, we have another endpoint and we have a line extending one direction indefinitely. And Lois, you're right. We can also times 2. So for example, in this one, we have 2 endpoints, right? We can also use 2 times 2, which gives us 4 rays. And similarly in here, because we have 3 endpoints, and each endpoint will give us 2 rays, so we can use 3 times 2, which equals to 6 rays. Okay? That will give you the same answer. Does it make sense now, Misha? Okay, that's good. So we'll move on to that first act question. So we'll have a look at this question. It's asked you how many rays are there in the figure below. So I will give you guys 3 minutes to do this question, and I want you guys to remember that each endpoint will give us 2 rays. Yeah? So let's start the timer. Just below 30 seconds, I see most of you have put in an answer. It would be great if you can all pop an answer down. Okay, so that's time's up. We're gonna stop answering. So congratulations to those who chose C as the answer. So I'm gonna give you guys a trophy for selecting the right answer. And for this question, we're trying to find how many rays there are in the figure below, right? So what do we do first? We look at the endpoints. How many endpoints are there in this line? Yeah, good job, 6. Okay, so we have 6 endpoints here on the line, and we have covered that for each endpoint there will be 2 rays originating from that endpoint, right? So for the number of endpoints, if there's 6, we're just gonna add 2 6 times. So we're gonna do either by adding them, so we could do 2 plus 2 plus 2. So I'm just gonna do this 6 times, which will give us 12, or we could do it in a more simplified way. So we just multiply by 6, which is 12. So what's this 2 here? This 2 is the number of rays that can come out from one endpoint, and the 6 here is the number of endpoints that we have, which gives us a total of 12 rays. Does this question make sense? Yes? Now we go to part B of the Act 1 question. So we went through the previous one together just because it's the first question. For this one, I'm gonna give you guys again 3 minutes to do it, and then once you guys have all finished, we'll invite someone on stage to explain it to us. Okay? So start a timer. Okay. Gonna close the chat box for now. Just want to give you guys a hint for this question. They're asking how many rays are there in the graph below, which includes both the line A and then the line B. Okay, so it's the total number. Just about 20 seconds left. Make sure you pop down your answer before the timer ends, okay? So the correct answer for this question is D, which is 18 rays, okay? So good job. And we're gonna give you guys some rewards for answering this one correctly. Okay, anyone want to hop on stage and help us? Let's see. Keaton. Hello, Keaton.
Good.
So
My
would you like
answer
to
is
explain
B.
to us?
Yeah. Is it okay if I use the pen?
Yeah, of course. You okay with finding the pen? Or if you want, I
The
can
pen
draw it
doesn't
for you.
work. I don't. Oh, yeah. Get it. I've already got it now.
Okay, that's good.
So
Okay.
each can go 2 ways.
Yeah.
So in total there is. So each dot can do 2 ways, one that way and one that way.
Mm-hmm.
So then in total there were 9 dots. So
Yeah.
9 times 2 equals 18.
Yeah. Anything else you want to add?
And that's all.
That's all. Okay. Well, thank you so much. Give you a trophy. So, let's just get off stage first. So what Keaton did there, he just did it in one go, and he counted the total number of endpoints in here, which is for line A we have 4 endpoints, and for line B we have 5 endpoints. So Keaton added them together, which gave us 9 endpoints, and he used the 9 to multiply the 2 rays that will come out of each endpoint and gave us 18. Okay. Or if you want to take it slower, you could also do them separately. You can look at line A first, which has 4 endpoints, multiply that by 2, which will give us 8 rays coming out from this line A, or this figure A. And then we also look at figure B, which have 5 endpoints, and multiply 2, which will give us 10 rays coming out. And here, adding them together, 8 plus 10 will give us 18. So both ways, they will come to the same answer. It's just that one would do it all together in the same go. So if you think you're getting quite good at it, you could just do it in one go because it's a lot faster. Or if you want to take it slow, you can do it separately. It's totally up to you. It will give you the same answer. Okay? How did everyone find that question? Did it make sense? That's good. So we're gonna move on. Next, we're gonna study how to find the number of rays when 2 lines intersect each other. Okay, so how would that look? So you would have 2 lines. So A and B here, they will cross each other, okay? Or if you look at figure B, you would have 3 lines actually intersecting each other. So it's looking a little bit more complicated than before, but I think you guys can handle it. So what we're gonna do is that first we're gonna find the number of rays on line A and line B. So we're gonna look at them separately, okay? And then we're gonna find the answer. So we're gonna do this question together. let's just change the color to red. Okay. So for the first one, let's have a look. If we look at line A first, how many endpoints do we have on line A? Someone want to tell me in the chat box? How many endpoints do you see on line A only? Yeah, so we have 6 endpoints there, right? And we know that each can have 2 rays. So we're going to multiply 6 by 2, which will give us 12 rays. Now we're going to look at line B. How many endpoints is there on line B? Yes. Okay, good job, Chantel. So we have 5 endpoints on line B, and we're going to multiply by 2 again to give us 10 rays in total. And then we're going to add them together. So we're going to add 12 plus 10, which will give us 22 rays in total. Okay, good job. Okay, so just one thing that I want to mention. You see this dot here, this endpoint, is kind of shared by line A and line B, isn't it? So you might wonder, do we count it in both line A and line B, or do we just look at it once? So let's bring that point out. We're gonna pretend nothing else exists, okay? So we have the 2 lines, and this is our only endpoint on here. And then we're gonna count how many ways we have that's coming out from just this one endpoint. So you see, it could go this direction, right? So that's 1, or it could go this direction, 2, or up, or down. So we're gonna have 4 rays coming out from this endpoint only, which means we will count it separately in line A and line B. Does that make sense? Okay. So that means in question 2, in here, when we see this capital B point and this capital C point, these two will follow the same principle as what we just went through there, okay? So let's look at question 2. Gonna make some space for the drawing. So for question 2, we have upped our challenge. We're gonna have 3 lines here, okay? So we're gonna start from A. How many endpoints on line A? Good job. We have 3 endpoints on line A, and we're gonna multiply that by 2, okay? Which will give us 6 rays. And let's look at line B. How many endpoints do we have on line B? Yes, we have 4 endpoints, and again, multiplying that by 2 will give us 8 rays. And what about line C? Yes, we have 5 endpoints, and multiply that by 2, we would have 10 rays. So we're going to add them all together. 6 plus 8 plus 10 will give us 24 rays. So did that make sense, everybody? And are you all comfortable by using the multiplication? So we multiply by 2 instead of just adding 2s, because that would take a long time. Yes? Okay, that's good. So gone through the question 2 as well. So we're gonna go to our next act question, okay? So I'm gonna close the chat box for now, and I'll get you guys to do this. Give you guys 3 minutes again. just below 30 seconds left. Thank you for answering. We're gonna give a trophy for everyone that answered the correct, chose the correct option, okay? So we're gonna find someone come upstage. Hi, Misha. Can you explain to us what you did in this question?
Yeah.
Yeah? Do you want to draw on it?
Yeah.
Sure.
So you got B.
Yes.
And then there's 4. So I did 4 times 2 equals 8.
Mhm.
And then I did C. So I did 6 times 2 equals 12. And then I did A. That was 6 again. Times 2. So and then I add them all up. 12 plus 12 equals 22. And then 22 plus 8 equals 32.
Yeah, 12 plus 12 equals 20.
4.
24, yeah, there you go. So you got the right answer, 32 there. Okay, thank you for explaining it to us. Give you a trophy. Thank you. So did everyone understood what Misha said just then? Yeah. So I do want to add something. Um, there's a couple that chose A as the answer. I just want to remind you, if you don't want to do the ABC, do each of them separately, and you want to do it in one go, just remember to look at the one or to look at the endpoint that is on the intersecting point. Okay, so you see how A, we're gonna name this with capital letter A. Okay, this endpoint A is being shared by A, B, and C. So you gotta count that in line A, line B, and line C, which means when you add it, you gotta count this point how many times? 3 times, okay? If you only count it once, you're gonna get the wrong answer. So if you do wanna count all of the dots in one go and then multiply that by 2 to save time, just make sure you be really careful of the points that's on the intersecting point, okay? Because you do gotta count it for the number of times that it's being shared by separate lines, if that makes sense. So now we have learned rays, and hopefully everyone understood, and we're going to go ahead and study lines, okay? Let's see. It won't be if you have endpoints on the end of each line. So, what is a line? There's a line shown below, which is a straight line that has no endpoint and can extend indefinitely in 2 directions. So I do want to circle the keywords for you guys. No endpoint here. extends indefinitely in two directions, okay? So we can see in this line, we don't have any endpoint like the race, and then it could go in both directions, yeah? So this line extends in both directions. And what are parallel lines? So when two lines never intersect in a plane, so they're never going to cross each other, these two lines are parallel to each other. Or we can say these are a pair of parallel lines. So for example, the two rails on the railway are a pair of parallel lines. See, they run in parallel and they will never intersect with each other. So let's give it a try. Which of the following in question A is a line? Yeah, so B, that's correct. And which of the following in question B is a pair of parallel lines? Yes, so we have D. Okay, good job. So we're going to try a question now. How many pairs of parallel lines, respectively, are there in the three graphs below? So what we're going to do in step 1 is to find the number of pairs of parallel lines. So in the first one, how many pairs can we see? One pair, yeah. Because how many lines do we need to form a pair? Good job, yeah, two, exactly. So we have two lines. That means we can only form one pair. Okay, so in the first one, our answer would be that there is one pair of parallel lines. What about in question 2? How many pairs can you see? So I see. Yeah. So let's draw it out, okay? So we could have this line and the second line, okay? Or actually, you know what? I'll do something better. We're gonna name them A, B, C. We could have A and B form a parallel pair, right? Or we can have A and C form a parallel pair. Or we could have B and C forming a parallel pair. So that gives us how many pairs in total? Good job. What about number 3? Yeah, let's give it a try. So we could have AB or AC forming a pair or AD forming a pair. So that's 3. Or we could have BC or BD plus 2. Or we have CD, right? Plus 1. So that's 6 in total. So to find the number of pairs of parallel lines, we need to sum up all the positive integers starting from 1 in the ascending order until the number that is 1 less than the number of parallel lines. So what that means is that when there's 3 parallel lines, we have ABC, 3 minus 1 is equal to 2. Okay, so there are 1 plus 2, which equals 3 pair of parallel lines. And here, when there are 4 parallel lines, 4 minus 1 is equal to 3. So there are 1 plus 2 plus 3, which equals to 6 pairs of parallel lines. So I'm just going to go through that again because it can be a little confusing. So what it means here is that we sum up all positive integers starting from 1 in ascending order. until the number that is 1 less than the number of parallel lines. So we're going to look at this part first. 1 less than the number of parallel lines. We're going to look at this question, okay? How many number of parallel lines are there in this question? Or just how many lines are there in this question? 3, right? And the number that is 1 less than the number of parallel lines is 3 minus 1. Three minus 1, which equals to 2. So this is what they mean by number that is 1 less than the number of parallel lines. And then we're going to look at what they said about sum up all positive integers. What does sum up mean? Adding up, yeah? So we're going to add up all the positive integers starting from 1 in the ascending order. So ascending, we're going to go up. So what we do is that we're going to go from 1, and then we go up 2, until the number that is 1 less than the number of parallel lines, which we found that number is 2. So we're just going to go up from 1 until we reach that number, which is 2 in this case. And that will give us 3 pairs in total. Does that make sense, everybody? Yeah. So just to go through it again, I'm going to try on the example on the bottom here. Okay, so we're going to find out a number that is 1 less than the number of lines first. So we have 4 lines here. We're going to subtract 1, which will give us 3. And we're going to start from 1, and we're going to add up by going up by 1 each time until we reach this number that we just found, which is 3, which will give us 6 in total. That makes sense? Okay, Fernando, what do you say that we go to a question here first? Because we just explained it with the example here, so I think it would help if we do a question together, and I'll explain it using the question. Okay, so again, I'm gonna give you guys 3 minutes. How about I'll give you guys 2 minutes for each question. So we're gonna start with question 1 first, okay? Let's do question 1 first. Close the chat for now. So just to repeat, we're only gonna do question 1 first, okay? There's about 10 seconds left. Make sure you pop in an answer. Good job to those that answered correctly, which is B. Okay, B is the correct answer. Give you guys an award. If that is okay, I am just gonna go through the first one, and then we'll give someone a chance to go through the second one with us. Yeah? So I just want to go through it again because this one is a little bit confusing. I want to make sure all of you understood it before we move on to question 2. So like we said on the last slide, what we're gonna do first, we're gonna find out how many lines there are in total. Okay, so can you guys tell me how many lines or how many lines that are paralleling each other is there in total? There are 5 lines in total. Okay, so we're gonna have 5 subtract 1 to find the number that we want to reach in an ascending order, which is 4. And then we're gonna start from 1 in ascending order, so we're going to go up every time. So 1 plus 2, and then go up, plus 3, and then plus 4, until we reach a number, which is 4. And the sum will give us the total number, or total number of pairs of parallel lines in this figure, which in this case will be 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, okay? Does that make sense? Good job, Michelle. Okay, which um Eden, would you like to tell me which part of it that you're a little bit confused about so I could explain it again? And Emily as well. So we're just going to quickly go back to this slide. To find the number of pairs or parallel lines, what we want to do is that sum up, which is to add all the positive integers starting from 1 in the ascending order, so going up until the number that is 1 less than the number of parallel lines is reached. So because we want to reach the number that is 1 less than the number of lines, that's why in step 1, we're going to subtract 1 from the total number of lines. Because that will give us the number that we're trying to reach when we add them all up. And when we add them all up, we go in the ascending order, so we go up in the numbers, and we start from 1. And we end with the number that we just found by subtracting 1 from the total number of lines. So this is a shortcut that will give us a very quick answer to how many pairs of parallel lines there are in the picture. Okay. I hope that makes more sense, and just for you to, sorry, not break, yeah, just for you to understand the concept better, we're gonna start with the question 2 from this act, okay? We can't do times 2 because that was for the rays question, because every endpoint will give us 2 rays going from each direction. But now we're looking at parallel lines. So just like what Mona said, if you're having trouble with the calculation method, you can always try to count it, okay? So if we go back to here, you can count it. So you can name your lines A, B, C, D, and just go in the alphabetic order. And we can look at, so what's parallel to line A? AB could form a parallel pair, or AC could form a parallel pair, okay? And then if we look at B, we could have BC, which form a parallel line. So why do we do this mathematical method is that if you start from A, and we look at how many pairs can we form with the line A. So we can have AB, which is 1 pair, or AC, which is 2 pair, right? And then we're gonna add how many pairs can we form with the line B. So we already counted AB, so we're not gonna repeat that. We're just gonna have a look at B and C, which is 1 pair. And then that will give us 3. So you see why we do the ascending order is that we're gonna always start with 1. But what's the biggest number that we're gonna add is gonna depend on the number that we're gonna find here, which is 1 less than the number of parallel lines. Because you see, if we start from A, even though there's 3 lines, we can only form 2 pairs. That's why we're gonna subtract 1 from there. Does that make more sense to why we use that calculation method? Okay, so how about we give question 2 a try? Okay, so again, I'm gonna give you guys 2 minutes, starting from now. And for this one, I would like one of you to come up stage and explain it to us, if that's okay. I'll bring up the selector. It's about 30 seconds left. Okay. So the correct answer for this question is C, 15. Let's have someone upstage to explain it to us. Hello, Keaton.
Yeah.
Do you want to explain it to us how you got to the answer?
Yeah. Can I borrow the pen?
Yeah, of course. 1 second. There you go.
Okay. So there could be, firstly, there was 6 lines.
Mm-hmm.
So you can, so then you you can do 6 minus 1 is
Yes.
equal to 5.
Yeah. I'll move it to the center here.
And then, so then it will be then it'll be up to 5.
Yeah.
Check. And then 1 plus 2 plus 3 plus 4 equals 10. 10 plus 5 equals 15.
Yeah. Good job. Thank you so much. Give you a trophy. I hope that makes sense for everyone. So what we did, what Keaton was saying is that he followed the steps that we went through. First, we found the total number of lines, which is 6. Then we subtract 1 to get the number that we're going to go up to. And then we add, starting from 1 in going up order till 5. And the total is 15. Anybody have any questions? Yep. Riley, just make sure you pop your hand up quick, okay? Good. So we're gonna have a break. Let's have a 5 minutes break, okay? So I can explain to any questions that you guys have during the break time. If you wanna pop them in the chat. Oh, a chess tournament. That's cool. I wish I knew how to play chess, but I don't. Did you have any question, Ella? Or does not really mean not really any questions? Oh, you have a netball game. Good luck to your netball game and the chess tournament. I'm sure you guys will do really well in those. What competition are you gonna go to, Fiona? Oh, gymnastic competition. I used to learn gymnastics when I was little, but I can't do any of it now. It was pretty fun, but you need a lot of practice, right? To make sure you're flexible and then you can do all the combinations. Cool. It's like an athletics competition. Where are you guys all from? I was from the Gold Coast, but now I live in Brisbane. What about you guys? Okay, we have New Zealand, Sydney. Okay, yeah, I'm Chinese as well. New Zealand, China. Yeah, I'm Chinese as well. Can you guys all speak Chinese? Going to Chinese school? Yes? Oh, wonderful. So you're bilingual. Anybody learning a third language? Yeah? What language is that, Isaac? Oh, actually, he's learning Japanese. That's cool. Oh, good job, Catherine. I can speak a little bit of Spanish. I learned it in high school. I'm not fluent in Spanish. Oh, Italian. That's cool. Play the violin. Oh, that's nice. Are you in a band, Olivia? No? Just playing by yourself, like solo? We also have cello, piano. You guys are very talented. Oh, Catherine, I play flute as well. Okay, so that's the end of our break time. We're gonna have to continue so that we're on track. So I'm gonna close the chat box for a second. We have just learned simple problem solvings, simple problems involving the number of pairs of parallel lines. Now we're going to study more complicated problems relating to parallel lines. Okay, so in this question, we're going to see how many pairs of parallel lines are there in the graph below. So just going to open the chat box. What we're going to do here is that we're going to kind of group them. So you can see that in this figure, it's very nice. They put it in color for us. So you can see all the red lines, they're in the same direction. So these red lines will form parallel pairs amongst them. And if you look at the black lines there, they go in the same direction as well. So the black lines will form parallel lines amongst them. But a red line and a black line, because they're intersecting too, so they're not parallel lines. That's why we're gonna look at them as two sets. So we have the red sets and then we have the black sets. Okay, so let's go just make it easier. We're gonna say the red the red lines, we're gonna call them set A, okay? And then the black lines, we're gonna call them set B. Let's look at A first. So we're gonna use the exact same method that we went through. We're gonna see how many lines there are in this set. And that's a total number of how many lines in the red set? 4 lines, right? So we're gonna use 4 minus 1, which will give us 3. Yeah, I know this one looks a little bit hard, so just bear with me. I'm gonna try to explain it so it makes more sense. Okay, so just try to ignore the black lines for now. So just think of the red lines, which I'll draw on the side. So just look at this drawing. Okay, so we have 4 lines. They're paralleling lines, right? And we have 4. So we're going to use 4 minus 1, which will give us 3, which is the number that we're going to go up to when we start adding from 1. And we go up plus 2 plus 3. That's the number we're going to stop at, which will give us a total of 6 parallel pairs. So that's in the set A. If we look at set B, which if you guys want, I can draw it out as well to make it easier. We have 1, 2, 3, 4, 5 lines. We're going to use 5 to subtract 1, which will give us 4, okay? And then we're going to add from 1 up to 4, which will give us 10 pairs. So adding these together, we can see that there is 6 plus 10, which is 16 pairs altogether, okay? It is a little bit hard, but does that make sense? So we look at them separately as two sets. We group the ones that are paralleling. So the red ones, yeah, in one set, and then the black ones in a second set. So if anyone has any questions, you can tap it in the chat box, or otherwise we're gonna move on to a question for you guys to do. That sound good? Yep. Okay. Let's go to